Education Bureau in collaboration with Addis Media Network. I'm teacher Mamu. Today we will see about the sixth unit, which is a circle. Okay, so unit 6 is about circle. Okay, so under this unit there are two major subtopics that we will be discussing, and the first one is simply about a circle and its related concept, and the second major subtopic that we will have in this unit is real-life applications of a circle. Okay, so before we see some terms regarding circle, I will tell you different terminologies regarding a circle. We will also see the definition of a circle. Okay, so let us formally start our discussion by defining a circle. Okay, definition 6.1 is about the definition of a circle. We define a circle like a collection of points which are equidistant from a fixed point. Okay, a circle is a collection of points which are equidistant from a fixed point, or sometimes we call it a locus of points which are equidistant from a certain fixed point. Okay, so a circle is a locus of points, which are equidistant from a fixed point. Okay, in a circle there is a fixed point, and each of collections of points are equidistant from a fixed point. Geometrically, if you have a certain circle, yeah, it's a fixed point. Good. So here, if you have this circle, usually the fixed point is the center of a circle, and all the points on this circle are at equal distance from this fixed point. And usually that fixed point is called the center. And the center is usually represented by capital letter O. Okay, so this point, and any point on the circle. Okay, you can take any point on the circle, say A. Okay, OA, this distance is called the radius. Okay, the radius of a circle is a line segment joining the center and any point on the circle. Okay, you can have a radius in this case. Okay, if you draw O to B and O to A, the lengths are the same. This is radius. Okay, you can have infinitely many radius. So don't forget, whenever we discuss about a circle, you need to keep in your mind that there is a center which is called the fixed point, and the distance between the fixed point or the center and the point on the circle is radius. So if we say this much, let's see some other terminologies associated with circle. Okay, definition 6.2. In definition 6.2, we will see 4 terminologies. The first one is a chord. Okay? A chord. A chord of a circle is a line segment joining 2 points on the circle, right? For example, if you have a circle like this, say this is a line segment joining the point A and B. Okay, by definition, a chord of a circle is a line segment joining 2 points on the circle. Therefore, AB is called a chord. Okay, so a chord is a line segment joining 2 points on a circle. Okay, this is one of the terminology that we need to be familiar with, because knowing all the terminologies in the circle are very important for our discussion that we will have next, right? So one of the terminologies, a chord. The second one is a diameter. Okay, diameter of a circle is also a chord, but diameter is a line segment passing through the center, and which is assumed to be the largest chord. Okay, so assume the center of the circle is somewhere here with center O. The diameter is a chord passing through the center and joining 2 points on the circle. Okay, it can be sketched in any manner, but it should pass through the center. Okay, so diameter is a chord passing through center of a circle. Okay, you may be asked to name the largest chord in a circle. If you are asked to name the largest chord in a circle, your answer should be diameter. Okay, so both of them are a chord. Their difference is diameter is a chord passing through the center. So this is the second terminology. The third terminology that we have here is a secant. A secant. Secant of a circle is a line that cuts the circle at 2 points. Okay, so secant, geometrically, you can have a certain line that cuts the circle at 2 points. Okay, the end point need not be on the circle. Say this is L1, and L1 can be considered as a secant. A secant of a circle is a line that cuts the circle at 2 points. That's all. Okay, so that line is called a secant if and only if it cuts at 2 points. Okay, and the last one is tangent of a circle. Okay, tangent of a circle is a line that touches at only 1 point. Okay, tangent of a circle is a line that touches the circle at only 1 point. At only 1 point. Okay, these four terminologies are very, very important. I will tell you again. A chord is a line segment joining 2 points on the circle. A diameter is also a chord, but a chord passing through the center. A secant is a line that cuts the circle at 2 points, okay? And the last terminology is tangent. A tangent of a circle is a line that touches the circle at only 1 point, okay? These are very important terminologies that we will be using in our discussion. So you need to sense what we mean by tangent, okay? Geometrically, a tangent of a circle is a line that touches the circle at only 1 point. So L2 is considered as a tangent line because it touches only the circle at 1 point, okay? So whenever you see different lines, you have to understand whether it is a secant, a diameter, or a chord, or a tangent, okay? So these are some of the terminologies that we have. Now let's see some of the basic formulas that we need to know in circle, okay? So areas and circumference. Now let's see what the areas and circumference of a circle looks like. Because knowing the areas and circumference of a circle is very basic and helpful to understand the next unit, which is about solid figures. So the area of a circle is dependent on its radius, and it's given by pi r square. Okay, the area of a circle is pi r square, and the area, the circumference of a circle is 2 pi r. Okay, circum means circumference of a circle. So the circumference of a circle is 2 pi r. Okay, 2 pi r is the formula that we use to calculate the circumference of a circle, and pi r square is the formula that we use to calculate pi r square is the formula that we use to calculate the area of a circle. So knowing these two is very important. So based on this formula, let's see two examples, then we proceed to the next point of discussion. So let's take example 1. So given the radius of a circle where r is 4 centimeter. Okay, if you know the radius of a circle, you can easily calculate the area and circumference. So given the radius of a circle, find the area and circumference of this circle. A circle. Okay, so we only need one information to determine the area and the circumference. We already have the radius. Both the area and circumference are dependent on the radius. When the radius is increasing, the area of a circle will increase because they are directly proportional. And when the radius is increasing, clearly the circumference will also increase. Okay, the circumference refers to the length of the circle. Now, based on this, in the first example, we are asked to find the area and circumference. So the only thing that we need here is the formula. So the area of a circle is pi r square. Okay, so this is pi times 4 centimeter square. Okay, so this is 4 centimeter times 4 centimeter is 16 centimeter. So this becomes 16 centimeter square. So this becomes 16 times pi times centimeter square. Okay, sometimes pi may be given in the form of 22/7. Unless 22/7 is given, you need to put pi in its place. Okay, when we come to the circumference, I prefer to use C because it matches with the naming. Okay, I need you to use, in place of this A1, capital C, so that you can identify whether it is circumference or area. So the circumference of a circle is defined by the formula 2 pi r. Okay, so this is 2 pi times the radius. The radius is 4 centimeter. So 4 centimeter times 2 is 8. So this product gives us 8 pi centimeter square. Okay, this way you can calculate, if the radius is given, you can calculate the area and the circumference. Now let me change this example in a little bit different way. Okay, I will give you the circumference and you will calculate the radius and its area. So let's see the second example. In the second example, given the circumference of a circle 20 pi centimeter. Find the radius and area of a circle. Okay, now in the second example, what is given? The circumference of a circle is given. So based on this given, you are asked to calculate the radius and area of a circle. Okay, so as you can see, the circumference is given as 20 pi centimeter, right? So we go back to the formula. Okay, the circumference of a circle is given by the formula 2 pi r. Okay, 2 pi r, where this capital C refers to the circumference. Now, based on the information that we have there, the circumference is 20 pi. So in place of C, you can substitute 20 pi. 20 pi is equal to 2 pi times the radius. Now you can calculate the radius by dividing both sides by 2 pi. Okay, divide it by 2 pi here. Now r becomes 20 pi over 2 pi. Pi by pi will be cancelled out. 20 by 2 is 10. Okay, since the unit is centimeter, the radius becomes 10 centimeter. Okay, which is the answer for the first part. Next, we are also asked to calculate the area of a circle. Now, if you have the radius, calculating the area of a circle is a straightforward activity. So, area of a circle is pi r square. This is the formula. You need to know the formula to calculate the area. Otherwise, you cannot calculate it. So now r is already known. So this becomes pi times 10 centimeter square. Okay, 10 centimeter square means 10 centimeter times 10 centimeter. As you all know, 10 times 10 is 100. And centimeter by centimeter is centimeter square. So we have pi. So the product of this thing becomes 100 pi centimeter square. So this is the required answer for the second part, right? So this way you can calculate the circumference, the area, or sometimes you may be asked to find the radius, right? This is enough regarding circumference and area, but you need to take one more point, that is the relationship between the radius and diameter. As I have said earlier, in our definition, we said that the diameter is the longest chord, and the longest chord or the diameter is twice the radius, okay? So keep in your mind that the radius is diameter is 2 times the radius, okay? You need to know this relationship, okay? Without the need to prove it, if you sketch any circle, you can clearly observe that a diameter of a circle is twice the radius, right? Then now we will see some other terminologies in circle, okay? Okay, that is arcs and its type. So what is an arc? An arc is a portion of the circumference of a circle. Okay, in our former definition, we have seen that a circumference of a circle is the total length of a full circle. Okay, whenever we say circumference, the length of a full circle is a circumference. So when we come to arcs, arc is a portion of a circumference of a circle. Okay, so arcs is defined as arcs is defined as a portion of the circumference of a circle an arc is defined as a portion of the circumference of a circle. Yeah. Well, so geometrically, if you have a circle, the full length of this circle is called a circumference. Based on this definition, an arc is a certain part or a portion of the circumference, right? So if you have 2 points, say A and B, okay, these pieces, okay, this piece is called arc AB, okay, arc AB, some parts of the circumference of a circle, okay? So this is arc AB. You can also say this is also arc AB. But to avoid a confusion, which arc you are talking about. For example, if you have some other points, C, now, if you want to talk about the bigger arc AB, you need to include C between A and B, okay? So arc ACB is this part of the circumference, and arc AB is the smaller portion of the circumference. So based on this situation, we can classify arc as major arc and minor arc, okay? Minor arc refers to a small arc, and major arc refers to the bigger portion of the circumference or the bigger arc, okay? So we classify arcs as major and minor, okay? Minor arc, okay? So in this specific picture, ACB is an example for a major arc, and AB is an example for minor arc. Sometimes our arc may be half of the circumference. Whenever we have an arc which is exactly half of the circumference, that arc is called semicircle. It's not major, it's not minor. An arc which is exactly half of the circumference is called semicircle, right? So you cannot put in major and minor. Usually, a semicircle is a circle whose degree measure is 180 degrees, right? So you need to keep this thing, because in our future discussion, we will have these namings. You need to sense what we mean by major arc and minor arc, right? So in terms of number, if you want to represent minor arc is an arc whose degree measure is less than 180 degrees, okay? That means it should be an arc less than a semicircle. And major arc is an arc whose degree measure is greater than 180 degrees, okay? In terms of figure, you can use this arc notation and ABC, something like that. In terms of figure, if you want to represent major and minor, you can say minor arc is an arc whose degree measure is less than 180 degrees. So this is also another common way of classifying arc, right? Good. We do have some other terminologies today, as I have said before. There are so many terminologies that you need to know so that you will understand our next point of discussion. So after arc, we have sector. Sector, okay? What is a sector? For example, if we have a certain circle, a sector is defined as a portion or a region which is enclosed by two radii and an arc that subtends it. What does it mean? For example, if you have this circle with center somewhere here, construct radii. Radii is a plural form of radius. Okay, if you have more than one radius, we call it radii, which is a plural form of radius. Now, a sector is defined as a region enclosed by two radii and an arc. Okay, so this region is enclosed by two radii and an arc, right? So this is called this is AB, if you want. We are not talking about the arc. We are now talking about the region enclosed by two radii and an arc. Okay, so we define a sector as a sector is a region enclosed by two radii and an arc. So now or onwards, whenever you see a certain region enclosed by two radii and an arc, that region is called a sector, right? Now we are going to classify a sector as major and minor, because this external part is also a region enclosed by two radii and a major arc, right? If you paint this thing another thing, okay, this region is also a sector, because this region is enclosed by two radii and major arc. So now, based on this situation, we classify sector as major sector, and minor sector. Okay, we call it major and minor. Okay, so the major sector is the big portion of a circle enclosed by two radii and an arc, and minor sector is a region enclosed by a smaller region enclosed by two radii and an arc. Okay, so this is another terminology that you need to know in the discussion of a circle. Now we are left with one more terminology for today, which is about segment. Okay, segment of a circle. Now, segment of a circle is a region enclosed by a chord and an arc. Okay, look, a segment is a region enclosed by a chord and an arc. Okay, look, in our former terminology, we have seen a sector which is enclosed by two radii and an arc. But when we come to a segment of a circle is a region enclosed by a chord and an arc, right? So this shaded region is considered as a sector based on our definition. So let me put the definition first. Then we classify segment as major and minor. Okay, a segment is a region enclosed by a chord and an arc. Okay, so if you consider this big portion of a circle, okay, this region is also a region enclosed by a chord and a major arc. So you will have two types of segment, okay? The smaller region, which is considered as a minor segment, and the bigger region, which is considered as a major segment. So you shortly classify segment as a major segment, okay, major segment, and minor segment. Okay, so you will have classifications. Okay, you need to specifically touch which region you are talking. Okay, either by using variables that represents the shaded region, or by specifying main, minor, and major. Okay, so these are the terminologies that we have in this lesson for today. So now I will ask you one very basic question regarding the terminologies that we have seen in this lesson. Okay, let me ask you one question. Which one of the following do not contain a chord? So I will give you choices. Okay, in choice A, take secant. In choice B, diameter. In choice C, tangent. D, none. Okay. Let me repeat what the question is saying. Which one of the following do not contain a chord? We already, we have seen different terminologies regarding circle, like chord, diameter, secant, and tangent. So, in this question, you are asked which one of the following do not contain a chord. So, think of this question. I will give you 30 seconds to think of the answer. Then we will have a common discussion. Okay? Just think of it. Okay, I hope you guessed one of these one of these four choices. Hopefully your answer is tangent, but you need to know the reasoning behind it. Our answer for this question is C. Look, the question says which one of the following do not contain a chord. As we have said before, a chord is a line segment joining 2 points on a circle. Right? So a chord can be on a secant line, because a secant line crosses or cuts the circle at 2 points. So the chord can be overlapping on secant. So it contains. A cannot be the answer, because we are not asked to find, we are just searching a line that do not contain a chord. So A cannot be your answer. When you come to the B part, in B it says diameter. As you all know that diameter is the longest chord passing through the center, so it has a possibility of touching or containing the chord. So A and B cannot be the answer. Why we said C? By definition, tangent of a circle is a line that touches a circle at only 1 point, but a chord touches the circle at 2 points. So there is no way for a chord to be on a tangent line. Okay? There is no way for a chord to be on a tangent line. So a tangent line do not contain a chord. So for this question, our answer should be C. Okay, so you may be asked this kind of question. I think this question was asked some years back in ministry examination. So I took this thing from ministry exam paper. So you need to answer this way. Well, so I will add one more things for today, then the theorem and their proof will be discussed by the next period. Okay, so let's see one more important concept in circle. Okay, that is central angle. Central angle. A central angle is an angle formed by two radii, okay? An angle formed by two radii where those radii are clearly intersected at their center, okay? For example, if you have a certain circle like this, okay? Say we have two radii, say this is R1 or R2, okay? Usually these two are the same, and we call a central angle whenever we have two radii, okay? The angle formed by any two radii is central angle, okay? Say this is all, take a certain point A and B here, okay? So angle AOB is a central angle, okay? Based on our definition, we already said that a central angle is an angle formed by two intersecting radii, right? So based on this definition, in this figure, angle AOB is considered as a central angle. Okay, let me tell you one more important relationship between the central angle and the measure of, the degree measure of the arc subtending it. Okay, so this arc AB, the measure of arc AB is the same as the measure of the central angle AOB, okay? AOB, okay? You need to remember this principle whenever we are solving questions related to central angle, okay? So keep in your mind that the central angle AOB and the arc that subtends it have the same degree measure, right? So we will see different examples regarding this central angle issues, but for the time being, I need you to keep in your mind that the central angle, the degree measure of the central angle and the degree measure of the arc that subtends it are the same. Okay, so this knowledge is very important whenever we solve problems related to central angle. So this is all for today. Today we have seen so many terminologies which are very important for our next discussion. So in our next discussion, we will see problems about central angle. We will also see some other theorems and their proofs, okay? So this is all for today. I hope you enjoyed the lesson. Thank you for listening.